Aditi, good evening. Hello.
Good evening, sir.
Good evening. Yesterday, did you attempt the test?
Yes, sir.
How is it? Easy, right?
Yeah, so I got 3 questions wrong, I guess.
Why? Which question did you get wrong?
Second, fourth, and fifth.
Second, fourth, fifth, huh?
Yeah, sir. Actually, I don't know which one is correct because I'm the only one who attended the question, the test.
Later you check it, that one?
So once can you explain those 3?
Oh, sure, why not? Just wait. What I'm thinking, mechanic, reaction mechanism, right? These questions, huh, I give. Which questions am I?
Yes,
This
sir.
one, second one.
Second, fourth, and fifth.
Second, fourth, and fifth, huh?
Yes, sir. So the answer for second one is third one, right?
Second one, yeah, homolytic fission produce always radicals, homolytic nothing but what is the suppose Cl is there. These two bonds are taking equally their share. Okay, this is breaking, they are taking equally the electrons, single electron. So heterolytic meaning different business. One is form the cation and one is form the anion. And homolytic nothing but these two electrons taken by both are sharing equally. After breaking this bond, what is the both are sharing these two electron equal, nothing but, so both two chlorines are getting one electron. Getting my point?
Yes, sir. And so what's the answer for the fourth and fifth one?
So second one understand, right? First one answer.
Yes, sir. Got it.
Next one, fourth one, huh?
Yes, sir.
If more number of methyl groups are there, then more the basic, right? See here only one is there. Here nothing else is there. You check it the second one, fourth one. Because of what is the methyl group is donating electron density. So when the electron density is donating, like this NH2 as the lone pair, right? CH3. Okay, this is CH3. Getting my point? See here, mama, it is donating electron, it is also donating. So more electron donation, okay, donation capacity of this group, that is one plus I group. So more electron density increases on the nitrogen. Nitrogen can donate easily this lone pair. Therefore, what is the basicity? Increases, right? Basicity increases. Sohan, Madhusudan, good evening, everybody. So do you have yesterday any doubts? This year I'm discussing. So now come to these two have the what is the second and fourth one as the more groups, right? So now here see here last one, if you see this one, this CH3, here what is the CH and this CH3, here what is the NH2. Okay. This is donating, so this is can donate more and more as compared to second one. Therefore, more electron density increases on the nitrogen can donate easily lone pair. That means what is the basicity increases, right? Now understand clear? Did you understand, Aditi?
Yes, sir.
Sohan, do you have any doubts? Also, then you also? No, huh? Next one, any other, you were asking some other question?
Fifth one, sir.
Fifth one, right? See, yesterday I told you, right? Okay, na? So which are the following as the maximum pKa? Listen, pKa value increases. So what will happen? Acidity decreases. This means what is the lowest acidic? Okay, least acidic amount, this one, which are the following. See, this is hydrogen. When a fluorine is there, it can pull the electron density, right? Suppose CH I'm taking here, CH2 here, fluorine is there, C double bond OH. So this fluorine is what is pulling electron density from a carbon. This carbon can pull the electron density, then oxygen can pull. Then oxygen can pull the more electron density from hydrogen. Hydrogen leave as H plus. Okay, easily. Right? Whenever oxygen is trying to pull the electron density from hydrogen, then hydrogen will leave as H plus, right? Easily. Okay?
Yeah,
Leave
sir.
easily. So when more electronegative group is present on this carbon, this adjacent carbon, this is called alpha carbon. So now obviously acidity increases. But what is asking the maximum pKa? Nothing but lower acidic value. So here what is the when any group is there donating group. Any donating group is it. This is donating. Donating nothing but what is the this carbon can donate. Then oxygen has the more electrons, it cannot take it in electron from hydrogen. Because of what is the this CH3 is donating electrons to the oxygen. So no need to take oxygen again electron from hydrogen. Now hydrogen cannot leave easily as H plus. Therefore, what is the acidity is decreases. Therefore, what is the answer is acetic acid. Next, any other? Got it?
Got it, sir.
Next one, any other? Only these are?
No, sir.
Fine. Next we'll go to our class. This is done, right? Next one. Reaction mechanism. This is your discussion, right? So everything we discussed almost. Next one on my second part is mesomeric effect. Very, very important this one, especially in organic chemistry. All these effects are very, very important. Whatever the doubts you have, immediately ask me. Effects are very, very, very important. Mesomeric effect. Okay. This is also called what is that resonance effect. What is the meaning of resonance? Anybody? Resonance, one more term is there in physics. Tell me.
So it's the different types of structures depending upon the bonds. Like if there are double bonds, for example, in benzene, we can take any, like there are two different types we can draw the structure.
Simple, Amma. In physics, one term is there. Resonance, nothing but in that term oscillation, right?
Sorry, sir. I thought I heard it as chemistry.
Yeah, that's okay. But just I'm asking. Just oscillation. Here also, what is the electrons are continue oscillation from the one orbital to another orbital. Okay, when that is called what is the mesomeric effect or resonance effect. See here, the delocalization. See here, one of delocation, nothing but what is the changing the location, right? Okay, delocalization. Delocalization of only 5 electrons. 5 electrons from. Okay, from. From what is taken the one cell to cell, nothing but right? Either orbitals or cell or subcell. Okay, one cell to another cell. See what is the cell I will explain. In the atom, what is the cell means? K, L, M, N, right? Or what is the subcell also, SPDF, all these things. Okay. See a delocalization, nothing but what is the changing the location of electrons. Change the location of electrons. So when it is possible, I will just do it. So when it is possible, delocalization, nothing but what is the changing electrons. So from 5 electrons from the one cell to another cell. See here, I will explain one simple thing. Try to understand this one. Suppose what is the C is there, double bond. Here what is the C? Here C double bond. Here okay, CH2 is there. Here what is the CH2? Here one hydrogen, right? So these two are what is the alternative double bonds. So how I am writing in the orbital section? See here, C I am taking in the C. Here a hydrogen is there, one hydrogen. So this pi bond you can write like this, right? This is the one pi bond. Okay. Next one, what is that? This is one. Another sigma bond. Here I am writing. So this is the one pi bond. Right? Pi bond. See, these pi bonds are continuous oscillating like this here. Continuous oscillation. Because of these are lobes are very, very low, less weight, right? So this and also pi bond can break easily. When these are continuously oscillating like this, continuously. So immediately what will happen? This can sometime attract this one, this orbitals. When it is orbital, nothing but what immediately it can form the bond, these bonds can break. So breaking and forming the bond, breaking, forming the bond, this is happened continuously. It can lose the what is the some amount of energy. It can lose the what is the some amount of energy. When any molecule is losing the some amount of energy, nothing but that molecule is stable, right? Very, very stable. Understand? So this is happening. See here how it is breaking. Suppose it is breaking like this. It is breaking. Just wait. It is breaking like this. It is forming the minus. This is the plus. So it is breaking. This is the minus and this is the plus. Now these two can form the bond. You see, C here, C is there, C is there, C and a hydrogen, hydrogen. So remaining hydrogen, I'm not writing amount because here see what is forming. Once these this plus and minus both are can form bond. So now it is forming the bond, right? So after that, what is happening here? Minus is forming. Here, what is the plus is forming. So what is happening next one? There I'm writing here one more time. That pi bond I'm writing here. This is on pi bond, right? Next one forming pi bond, new pi bond. So this is what is the one vacant orbital. This is what is as the lone pair like this. So again, they are continuously moving. Same thing. So after what will happen? These two can form the bond. Nothing but what is that? This can break. Here plus can form. Here minus. This minus okay plus both are from bond. This plus and minus both are can form bond. So again, what is the? This is the positive backside. Okay. So again, what will happen? These two can form the bond. Breaking of this one. This is what is the plus. So this is the minus. So these two can form the bond. Again, it is possible. So delocalization nothing but what in the both structures, okay na? Two structures are possible. This one is possible and this one possible. Okay. So this is represent the resonance. And getting management. So when it is possible, you simple first you have to understand when the double bonds are in the conjugation. Conjugation nothing but what is the alternative double bonds. See here, this is the one double bond. After a single bond is another double bond. So these two double bonds are alternative bonds. When it is alternative bonds, then only it can form the, it can what is the form the conjugation. Right? It can show the what is the resonance effect like this. So resonance, any structure it is following the resonance or mesomeric effect. That token structure is the more stable. That molecule is the more stable. Why? Because of see just now I told that breaking the bond, forming the bond, breaking the bond, forming the bond. So it is continuously happening in the molecule. So that's why it can lose the some amount of energy, it become the more stable. That's why what is the resonance stable? Resonance, okay, resonance effect having molecules are more stable as compared to normal molecule. See here. So what is the condition here? Just now we told that it should have the conjugated double bonds. Okay, it is observed. It is observed in what is there? Conjugated. Where conjugated. Nothing but what you can alternative. Alternative double bond present in the molecule. Bonds present in molecule. Double bond present in the molecule. Understand, right? My point? Anybody have the doubt? So you can ask that, sir. So why? Suppose these two bonds are there, adjacent bonds. Here for double bond, here double bond. Why it is not following like this? Here, what is the suppose I'm writing these two are on bond, right? These two are, so they can break it, right? So why it is not happening? See, in adjacent double bonds are these are called what is the cumulative double bonds. It is not okay observing the cumulative double bonds. Anybody know what is the reason? Okay, listen. I will explain carefully. Listen carefully. See here, if you observe carefully this one, see these two 5 bond. Okay, these 5 bond both are in the same plane. See here. It is okay delocalizing like this. Then same path, okay, same plane. It is delocalizing. Then only what is the these two can break. Sorry, these two can collide. It can okay. These bonds can break and new bond can form. But when it is okay, opposite plane, suppose it is okay in this plane, another these two are in this plane. When this pi bond in this plane, if it is in this plane, so nothing but these two are exactly perpendicular to each other. So these two cannot collide, right? It is not possible. So that's why what is in cumulative double bonds, it is not possible. See carefully explaining. Resonance effect or mesomeric effect okay, is not observed in where cumulative bonds, right? Cumulative double bonds. Cumulative double bonds. Here example I am giving. C double bond here. C okay, C double bond. Here one hydrogen is there. One hydrogen. One hydrogen. One hydrogen. This is called alene. Okay, name is alene. Here I am writing in terms of what is the orbital structure. Here C is there, one C and one C, right? Here a hydrogen, one hydrogen. This is one hydrogen, right? Here you know already. If its middle carbon contains the two pi bonds, this is called what is the sp hybridization. This is what is the sp hybridization. This is the sp2. This is the sp2. I think you know already. Listen carefully. If it is the forming the one pi bond like this is one pi bond is forming. The same carbon it is forming the another pi bond here. So nothing but what is that orbital should be pure p orbitals. No two pure p orbitals on the one atom in the same plane. Impossible. All p orbitals are what is the perpendicular to each other. So that's why one p orbital. Suppose I'm taking in the x-axis. This is px I'm taking. Suppose I'm taking this is what is the px. This is what is the suppose px I'm taking. So next one, what is the py should be in opposite direction. This is what is the py. Both are what is the perpendicular to each other, 90 degrees. So obviously what is it is the forming pi bond, nothing but this should be py, right? So then these two can form the pi bond. See here, it is okay, these two lobes are okay. These bonds, this pi bond is delocalizing. So nothing but, sorry, in the oscillating in the what is the x direction, x axis. This pi bond is oscillating in the where? In the y-axis. See here, this is like this is exactly. But these okay, these two are perpendicular to each other. So once it is losing, this is okay in this plane, both are not okay collide at all. Getting my point? This is in the x direction, this is the y direction. How they can collide? Not possible. So that's why what is in the cumulative bond, cumulative double bonds, resonance is not observed. So when the double bonds are in the conjugation, then only it is observed. Okay, resonance. I hope you understand clearly. Anybody have the doubt? I will explain one more time. Please tell me. First. Aditi, you're fine? Sohan? Where is Sohan? Madhusudan.
Yes, sir.
Clear?
Yes, sir.
Yes, sir.
Yes. Next one. See, not only this one, you can say the okay, some 4 conditions, 5 conditions are there. You whenever you see this condition, you have to keep in mind, okay, there is a possibility of resonance effect. Conditions of the resonance. I'm explaining here. Conditions of resonance. First one, if 2 double bonds in conjugation. First one already you discussed, right? In the conjugation. Here, example, what you can do, C double bond here, C double bond here, C. Okay, right? Here one hydrogen is there. Here what is this? Two I'm writing. Here a hydrogen is there. This 2. So you know carbon can always form the 4 bond. Don't forget at all. See, Rama, this is suppose here. Listen here. So what it is forming here? pi bond, right? This is minus is forming. See, whenever minus is forming, nothing but this. Can I write like this? It is shifting. So these electrons are shifting to this orbital. It is forming minus. This is the plus. See here, okay, minus is forming nothing but this is shifting this side. This is forming the minus, here plus. See, every time we can't write them in these loads. Just what is the pi bond is shifting this side, here minus, positive is forming. This bond is also shifting, minus, positive forming. Both are forming the bond. So you can directly shift here. This can shift here like this. Here plus so, and here double bond, here minus like this. Okay. So that's why you have to follow this only. Okay. See here, this is suppose you are shifting here. This can shift here. So that means what is following here? Here I'm a double arrow. Sorry, you have to show. Here what is that? This one you can show. Either this one you can show double arrow directly. So here what is the CH2? Here minus is. Here what is the C? Double bond. Here C. Here hydrogen is there. Here hydrogen is there. Next one what is the CH2 plus is there. See, these electrons are shifting this side. Minus is forming. Where plus is forming. Only pi electrons, not sigma electrons. These two pi electrons shifting this side. Minus here, plus is forming. This plus so minus both are forming the bond. That bond is this one. So another possibility also there. So next one, what is the same molecule I am writing? Another molecule. So CH2 double bond here. What is the CH and open a CH double bond here CH2. Another possibility, what is the this can shift here and this can shift here. So now what can form here? CH2. This is shifting nothing here plus and here minus. So nothing but double bond is forming. Here what is the CH2 minus it is forming. See here how many resonance? This is the what is the original structure. These two are what is the charged form. So whenever the here whenever the more number of bonds are present, neutral structure, that is the more stable. So next one, what is the these two stable? So here you have to understand very important. First one, what is this one? I'm taking the first structure, second one, and third one. These two are same, right? Here. These two are same. So very, very important. Stability depend upon what is the stability. Stability. If you see the first one, stability, more number of bonds. More number of bonds. Okay, na? More number of bonds are stable. After that, what is the charge structure? First, you have to check it the whether any molecule has a more number of bonds. Here, this is 1, 2. Here 1, 2, 2. Okay, na? Total how many bonds are there? Suppose I am taking only the CC bonds only because hydrogen all are same, right? See here what is the 2 bonds? This is 1 bond, this is 2 bond. Total 5 bonds. Here 1, this is 2, this is the 1. Okay, total 4 bonds. You know already. Whenever bond forming nothing but it can release energy. So more number of bonds forming nothing but more much amount it can release. It is become the more stable. So that's why when you come to the stability order, first one is what is the more stable. First structure, after that what is the second one equal to what is the third one. Got it? Next one. Next one, second condition I'm saying. Second condition, what is the when double bond and lone pair are in the conjugation. When double bond and lone pair in the conjugation. You know lone pair nothing but how many electrons? 2 electrons, right? Lone pair in the conjugation. See example, whatever taking, suppose CH okay, 2 double bond here, CH okay, CH okay, double bond here. Sorry, we are talking about like sorry. See what I am taking the NH2. See NH2 has the lone pair. See how I am writing the orbital structure. CH2 double bond here, CH. Here what is the NH2 lone pair is there. So this is also writing in the orbital form. See this is the one orbital pi bond. This is the one orbital okay, pi bond it is forming. So now what is the here? This is breaking. Here very, very important. This can donate the electron density to this one. So nothing but it can form the positive, it is the negative. This means these electrons are shifting this side. Getting my point? Here I am writing this electron. These electrons are shifting this side. This is minus, this is the positive. Now these two are forming the bond. See, one is the vacant orbital. This electron donation towards this side. So what is this bond is called? Coordinate covalent bond. non-coordinate covalent bond. Okay. So plus is nothing but what is the there is no electron, it is vacant orbital. This is a negative charge. This electron can be donated to this one, it is forming the coordinate covalent bond. So once it is forming the bond, nothing but what is the this got the positive because it is losing the one electron. See, these two electrons shared by this nitrogen and this orbital is sharing. So nothing but nitrogen lose out of two electron, one electron, it is got the positive charge, right? See here how I am writing this one. In the simple form you are taking in the delocalized form. This is shifting and this is shifting. Now how can I write it this text? CH2 minus, okay, here what is the CH double bond NH2 plus is writing. Okay. When our lone pair is there. Not only this one, even suppose I'm taking the this is okay, A example, B example I'm taking. Suppose CH2 double bond here CH, okay. Suppose OH is there, any alcohol like this. See here one lone pair can be shift to this one, this can shift to what can form here form? CH2 here minus, and here what is the CH and double bond here OH. So obviously what is the oxygen losing one electron, nothing but it is got the positive charge, right? It got the positive charge. Clear? Next one, third one. Third one, when positive charge and double bond in the conjugation, double bond and positive charge in the conjugation. Positive charge in conjugation. Positive charge in the conjugation. Here I am giving the state. Okay. Positive charge in the conjugation. Here one molecule I am taking. Suppose what is the CH2 double bond here CH. Okay. Here what is the CH2 plus is there. See how I am writing the outburst structure. Here what is the CH. Here what is the CH2, right? Here CH. Here what is the CH2. See here plus is there, right? This plus I am taking the one vacant orbital. Plus is there. Here double bond, what is the here like this? Double bond. See same thing, same story. So these electrons are shifting this side. This is got the minus charge. This plus and minus both are forming the bond. This got the positive charge, right? So here how they are shifting. This is shifting this side. Therefore, what is the more final? It is forming the molecule resonance. Here CH2 minus plus is there. So what is the CH double bond here CH2, right? CH2 is forming. Got it? These two are forming. So the whenever what is the double bond and positive charge in the conjugation of the resonance effect is observed. So final one is fourth one. My negative charge in the conjugation. Negative charge conjugated with double bond, okay? Negative charge and double bond. Here finally, same thing I'm writing. Concept is same. CH2 here, what is the double bond here? CH. Here, what is the CH2 minus is there. Same thing I'm writing one more orbital structure. CH2. Here, what is the CH? Here, what is the 1 pi bond is there. Here, what is the CH2? Here, plus is minus is there. Minus nothing but what is the here 2 electrons are there. See, now it is trying to donate electrons. So when these electrons are shifting this way, it got the minus, here positive, both are can form the bond, right? That's why how I am writing that these electrons are shifting this side. Okay, now this is forming the bond. See here, simple writing, this is shifting here, these two are shifting here. So now what is forming? CH2 here minus is there, here CH, okay, double bond here CH2. Okay, forming the bond. Got it? Any doubt? So this is how the conjugation takes place in the four types of possible forms, right? Pi bond, when the double bond is in the double bond conjugation, double bond lone pair, double bond positive charge, double bond negative charge. Next one, types of plus M effect, mesomeric effect. See here, M effect, mesomeric effect or R effect, both are same. Resonance effect. Generally, resonance effect we will see on benzene. Mesomeric effect, nothing any other. But you can take both are same, right? Here what is the, in that what is the two types of there? One is what is the plus sum effect or plus R effect. So next one, what is the minus M effect or what is the minus R effect? Both are same only. Okay. See, so plus sum nothing but what is the it is donating the electron pair. See all these things here, observe carefully. Something it is donating electron pair. This is also donating. So nothing but this is also donating electron density, negative charge also. So next one, what is if you see the double bond, this is also donating electron density. See this okay, double bond is donating electron density to this carbon. So this is okay, lone pair donating to this carbon. Okay, this is also donating to this one. So like this here, what is the negative charge if you see it is donating? See, all these are donating electron pair. Minus charge nothing but electron pair, there, 2 electrons. See, everything it is donating the electron pair to the some other atoms. Whenever anything the donating the electron pair, nothing but that is called what is the plus sum effect. Okay, na? Plus sum effect. So group which can donate electron pair. Example, whatever taking NH2. NH2 can donate the lone pair, right? Okay. So next one, what is the OH? It can donate also electron pair. Next one, what is suppose I'm taking the NR, NH, so can a hydrogen if you take it can donate. So next one, like halogen also can donate because it has the lone pairs, right? So next one, what is the any other ROH if you take it, alcohols, it can donate. Next one, what is the CH3 minus, it can donate. So what is the minus M effect? So nothing but any group, it is taking electron density, lone pair of electrons. Here, suppose you are observing carefully, this double bond is there. This double bond is taking electron pair from the where, from this one. If that's why this is the what is the plus M effect, this is called what is the minus M effect. Okay. So suppose it is donating the plus lone pair, nothing but this is the plus M. It is taking the lone pair. See here, this lone pair is shifting here. So finally, it is forming what is their negatives are here positive. Here also positive, negative. So it is donating. This is the taking. That's why it is the minus M effect. Anything, any group is withdraw electron pairs like this. This group is called what is the minus M group. Any group. So you will discuss the what is the more examples. Then you can understand clearly. Group can withdraw electron pair. That is what is the example of just one. Suppose you are taking the CH2 double bond here, CH, C double bond O, H is there. One example I am doing. See here, observe oxygen is the more electronegative, right? It can pull the electron density. Aditi, you are getting everything? Madhusudan, Sohan, everybody?
Yes, sir.
Clear, right? See, observe carefully. If you observe carefully, this is oxygen is more electronegative, right? More electronegative, nothing but what you can understand here. It can pull the electron density like this. So once it is pulling electron density, nothing but what is the this electron, this double bond, pi electron can shift here. So this oxygen can take this one. See here, very, very important. This is shifting, nothing but what is here, minus is forming. Then immediately these two electrons can shift here, minus is forming here plus. The plus and minus both are forming the bond. Okay. So here how I am writing this one. What is forming here? CH2 plus is there. Here CH, okay, here double bond, here C, here O minus, here H. So this group, because of this group is pulling the electron density, lone pair of electron from the what is the double bond. This is called what is the minus M group. This is called what is the minus M. So like this, many are there. Not only this one. Here C double bond. If any carbon contains the C double bond, that is act as the minus M group because it can pull the electron density. It can take from other. Suppose here what is the NH2 I am putting on here. NH2. NH2 has the lone pair, right? This lone pair can shift here. This can shift here. That means what is that? This group is minus A or minus M effect. This group is what is the plus M effect. Simple. Because it is donated. Like in every situation, there is a plus and minus M is there. Suppose you are taking the sign C triple bond N. So this can pull the electron density. Suppose OH is there. This OH can give the electron density to this one. So neither. This is called what is the minus M effect. This is called the what is the plus M effect, like this. See everything, not only this one. In every case, many are there. Suppose if you take the N double bond here, and here what is it? NO2. Okay, NO2 can take the electron from the oxygen, can take electron from the nitrogen. Immediately, this nitrogen can take electron pair from the outside. So that's why it is also called minus M code. I hope you understand it clearly. Got it? Got it? Got it?
Yes, sir.
So you will see the some stability of carbocation. In that, what is the applications you will see? Very, very important. Applications. Before that applications, I'm explaining one small thing. You can understand more easily. Just I'm asking. Suppose if you take anything, CH, you can double bond here, what is the CH? Here, cyanide is there, right? Okay, cyanide is there. So you have to first understand which group is the minus M, which group is the plus M. How can you understand? Depend upon electronegativity. See here, nitrogen is the more electronegative. It is trying to pull the electron. Nitrogen is more electronegative, right? It's trying to pull the electron density from the carbon. And that too, this is the sp, highly electronegative. You know, right? S character increases, what is the electronegativity of that atom is increases. So that's why it is highly electronegative. When such situation is present, what will happen? This nitrogen will take these electrons. Then immediately it got the positive charge somewhat. So then immediately it will take the electron pair from this one. So like this. This is the what is the every time you are observing this kind of situation in every molecule. Whenever the conjugated double bonds is present, 100% you have to be remember. Remember that one. See, always there is a possibility of bond shifting from one molecule. This is the one cell, right? Pi bond. Pi orbital nothing but what is the one bond? One cell. Here it is shifting to another cell like this. See, this is the different cell. This is the different cell, right? Okay. That's why what I'm saying, shifting of electron to one cell to another cell. So once it is shifting here, this is shifting here. So now what is forming here? Here CH here plus is forming, here CH double bond, here C double bond N, and got the negative charge. This is got the negative charge, this is shifting here, this got the positive. This negative and here positive both are formed the bond. Direct overwriting. Got it? Suppose the same thing I am using this one, CH2 and double bond here CH. Suppose you are taking the NH2. Here lone pair is there, nothing but lone pair can easily shift. Very, very important number. Very. See here, what is you are not talking about the what is the sigma bond electron shifting. You are talking about what is the pi electrons are lone pair or negative charge electrons are delocalizing. Delocalizing nothing but completely location is changing. See, this electron location is here. Now it is changing to here. So this electron location is here. Now it is changing to here. Once you are shifting here, this carbon got the location. So completely changing their location, right? That's why it is called what is the delocating. Delocalization of electron. Location is changing. Sigma electron, nothing but minus A effect is there or plus A effect. What will happen here? Minus A effect, plus effect. Just it is the these two electrons can shift which which side? The element which has the what is the highly electronegative side. Okay. The bonded atom which has the more electronegative side, these sigma electron can shift. But here what is the completely delocalizing? Very, very important. Electrons are shifting. So now what will happen here? CH2 here minus is from here CH, okay, and double bond here NH2 here plus is from here. Okay. So in that first of some applications you will see, you can understand applications. In that first one, what is the stability of carbocation? You know, what is the carbocation? Stability of carbocation. stability of carbohydrate. Listen here, what is the two of the effects are applying? One is what is the plus M or plus A, plus M or minus M effect, and next one what is the plus A and minus M. Both are involved. See here, suppose I am taking the one example, CH2, here double bond, here CH, here CH2 plus is there. So you have to think about very well. Sir, what is the, this plus is there nothing but it can pull the electron through the what is the sigma bond. This is the one task. See what is the sigma bond, nothing but what is the minus A effect is there, this group. And these two are what is the directly donating. See here, this is the shifting electron, nothing but what is the only some electron can shift towards the what is the CH because of it got the positive or nothing but this is more electron. But think about it, these electrons are not completely delocalizing. So this positive charge is not completely neutralized by this sigma electron. But when these pi electrons are completely shifted to this one, here form the what is that bond. When bond is forming, nothing but energy is released. It is a highly stable. Therefore, what if you see this one in stability gauge? Okay, stability plus some effect, okay, increases. Here, what is the plus some donation capacity of this group is increases. What will happen? Stability of carbocation increases. Sir, same thing we explained what is the in minus plus I effect also. But both are operating now. But whenever this situation 2 are okay, is there, first you have to check is the what is the plus sum effect. Plus sum effect always. Any M effect, not only plus sum or minus sum, M effect or R effect. Resonant effect. Always dominates the what is the I effect. Very, very important this one. Why? Because of here electrons are completely donating them. Immediately shifting electrons. There is a formation button. But here sigma, it is not like just what is the these two electrons are moving toward the more electron. That's why it is not much effect. Okay? Understand? So anyway, tomorrow we will discuss the remaining part. Okay, we will discuss the more questions also. Anybody have the doubt, you can ask from this part. Otherwise, you can leave the session. Thank you so much. But practice, everybody. Practicing at home or not? Practicing at home or not?
Yes, sir, practicing.
Okay, good. Every day you have to practice. This is organic chemistry. If you don't practice, tomorrow it will open a 0 only. Everything you will go evaporate from your brain. Thank you, Amma. Bye.
Thank you, sir.